Mario once again with MIA Microflight, and this is the latest go-kart that I've been working on. This video is probably going to be part 11. This is the seat, the way I described in on video number 10. An aluminum piece that was part of a wheelchair that I obtained from my neighbor, and this was the back. This was the vertical side. This was the back, and it had sort of a curve to it. These lines right here were already there, so it made it easier for me to just take this line and bend it further so that I can create a seat at 90 degrees of what it was intended originally. So I peeled off the foam was stuck here. You know, I'm about to clean this really well so that I can attach Velcro strips, and those Velcro strips are going to be my my support for the for this bag that I made for this foam here. This is the foam pad that was originally part of that wheelchair back, but that I turned it into a seat. And so I just sewed this bag here from this material. This has a rubber backing, and it's got like a canvas texture at the front. I believe this is nylon. But it's very durable stuff. I think this is used for outdoor furniture. Maybe even called Sunbrella, you know, which is it's a trade name for fabric that is used on outdoor lawn furniture. So anyway, I made this basically just a sleeve, and the way I did this is, you can see the Velcro here. All the Velcro pieces are sewn. This is for to attach to the seat itself. These larger pads. There's another one inside. Once I turn this inside out, it will be able to see that, and it's actually underneath here. But everything is sewn. This is also sewn. This is going to be my zipper, sort of you know, just a very simple zipper. Once I turn this over, this will mate with this guy here, Velcro, and that'll create my seal. So I'm about to do that, and I'm going to pause this video while I do that, and I'll come back to it. Okay, so this is how it looks on the right side out. I flip this over, I inserted the foam, and this is just a sort of just a quick zipper. This didn't take me long to do this. I mean, I could have done this. I guess I could have folded this over the area here. I may need to clean this, you know, at a later time. But I just wanted to get this bag quickly done here, because I want to put this on the go-kart so we don't ride it without it. And these are the Velcro straps. One Velcro strap is going to go right at the top here, and then the two little pieces at the bottom here, as you see it right there, basically to match that. And that seat will go like that, nice and simple. If I need to wash it, if it gets dirty, I can just pull the bag just like a pillowcase, and it'll be done. Once somebody sits here, it'll conform to a little more, you know, have a little more curvature here. But I'm about to clean this out. I'm about to clean the seat here, because it's got these. It still has this foam that was stuck from there, so I'm going to use some gum out and clean this out, and I'm going to paint the seat black so that it doesn't look too distracting. As you know, this doesn't match the rest of the black go-kart. Yesterday I got some wheels that I ordered. These are the nicer wheels. These are solid tires. Very, very. Actually, they're the same pattern as these hoverboard motor wheels. I didn't know that. I got these wheels because of this similar size. These are 200 by 50, same as these. And so I got them for similar size, but I wasn't aware of that pattern. It matches. It's even better. These are the original. These are the wheels that I use from Razor 100s. These are the front wheels. Very nice wheels. They're pneumatic, you know, which take a little bit of a cushion, you know, if you hit a bump in the front. So I'm going to install these because they look nicer, you know, aluminum hubs to match the aluminum material that's used there. Not so much the pattern, but it's an aluminum wheel, so these are going to look nicer. I got these. I'm so happy with these. Very nice wheels. I also ordered some other wheels here. These guys right here. These are unfortunately these don't have 3/8 axles, or the hole on the ball bearings is not 3/8 but 7/16. So these are going to work out, I think, very nice. I got 4 of these. I'm going to modify the rear ones, to be either chain driven or maybe just chain driven with some of these scooter motors, because I got a bunch of these scooter E100s, 200s, 300s. Got a bunch of those that I need to do something with them. Otherwise, they're just gathering dust. So I'm going to make a couple more go-karts for my grandkids using these big wheels. They're going to be more compact for little guys, but they're going to be more serious. More sturdy, and I'm going to do it this kind of similar with the telescopic tubing. That tubing, same type of C brackets that I'm using on that one, same concept, because that is working beautifully. The C brackets for these are already done on the original go-kart that I did. I made them out of just a larger size telescopic tubing, and what I did is I took a section of that to create my spindle with the arm. So I cut a section about that long, and I trimmed this side right here so that it would be in the shape of a C, a long C. So I used that, at 90 degrees, bolted one side here, and put a bolt, a 7/16 bolt right there, and that's my spindle with the control arm. Real nice and simple, and that worked excellent too. So so these wheels are going to go right there. And so that'll be the go-kart. The only thing with this type of material is that these are sold by Home Depot, or you can get them at Lowe's. You can get them also online, I guess, from Zorro or one of those industrial places. The thing is that these have a spacing of 1 inch on centers. And finding brackets for this is, I think there's one individual who's making these custom CNC cutting them, and each bracket's like $10-13. It's crazy. $10-13 for a bracket like this. So what I did is I 3D printed this just to get the pattern or the bracket, get some samples, so that I can send out to a company that I'm trying to work with and see if they can manufacture the brackets. They're the same. It's the same company that manufactures the Maker Pipe connectors. In fact, it's Maker Pipe Connector, the name of the company. So they manufacture these connectors. If they can do that connector, which is more complex, I'm pretty sure they can do these brackets. Just with a die stamp, and I believe they own their own equipment. So maybe they'll take this up. I hope they do, because this would be a nice. It would be an extension to this market right here, which unfortunately, it's like this company developed this for signposts. Perforated signpost. It's great stuff. This is thicker than that 1.5 inch that I'm using there. So it's very, very sturdy stuff. But they made it for signposts, telescopic signposts. They have pins, you can attach things with bolts as long as. But if you want to do like an assembly, like a table, or in this case a go-kart, you need brackets. There's no bracket that fits this. And the one person that I stumbled upon, one vendor, it's like $13 for a bracket. It's too much. I paid $30 for a set of 6 of these brackets right here, and these are a lot bigger. So $5 a bracket would be more like it, but $13 is just way overkill. So there's no way that I would be buying those brackets. However, if somebody has the capability of die stamping this and make these brackets, $3, $4, even $5, I'm willing to pay for one of these, per piece. I think that's more in line with something that's more. Something that's more balanced in terms of price, in terms of cost. So I printed these, so I'm going to probably be sending 2 of these, to the company that I'm working with. I'm trying to work with and see if they can just manufacture this bracket to these dimensions. I mean, there's really, I don't even need to send the brackets. This is just 1 inch on center, and all you need is the width of the tubing, and you have your bracket, and a number of holes that you want, horizontal and vertical, and you have your bracket. But I did these, just for my sake as well, to kind of make a mock-up with this. Of course, you can't use this You could use these reinforced with a plate, but what's the point in doing a metal plate and sandwiching in between these two? You may as well just do the real thing. So um, that's my take on this right here, and I really love this stuff right here. This tubing, as I do maker pipe connectors, all the stuff that they produce, because all this stuff is excellent for for if you're a tinker, if you're one of those people that grew up with erector sets and you're you're into mechanical engineering and assemblies, this stuff is awesome. Any type of connector that allows you to connect things fast is great. Even this stuff right here, even though it's not perforated, with the proper brackets, I found these brackets which are excellent for this stuff right here. Even this is great, because all you do is put the bracket on the where you want it to drill the holes on the tubing. Clamp it, make sure it's nice and even in line with this tubing, square tubing. Mark the holes, punch the center of the hole, and drill, and you're done. Hopefully you have a drill press to do this, because this is not done on a drill press. It's not done by hand. So that all the holes come out perpendicular to the to the structure. So that's what I'm working on. As I said, I'm going to take out the seat, clean up. One thing that I ran some. I already ran this a couple nights. I've been riding this around my neighborhood here. I went to the park, and it rides so it can not ride as good as I would like it to ride, because it doesn't have suspension. So every bump you feel it. But I'm gonna get to that in a little while here. But the control is awesome. It's got excellent turning radius, excellent control, and that is because I was very careful when I designed these brackets. And once again, these brackets are same thing that I was talking about for the perforated tubing, the one that's sitting over there. The way I did that, and unfortunately, I guess I could have used, because they do make a 2-inch pipe, 2-inch square tubing rather, that I could have manufactured these brackets, from the 2-inch pipe, similar to I did with a perforated tubing, telescopic tubing. But I decided to go, and I'm glad I did it this way, because this is 3/16. Yeah, that's 3/16 steel, raw steel that I got at Home Depot, and even though it's quite a bit of work, to do this, and you got to have the right equipment to do what I'm going to describe. You have to buy the material. You got to have a grinder with both thin blades and wide blades. To the wide blade to use it as a sander, or just to ground off the rough edges, and the thin blade to cut. And you got to have some kind of a jig or something with a grinder, so that you can cut perpendicular. You want to make straight cuts. You don't want to do it by hand, because you do it by hand. Although some people have done kind of similar stuff by hand, not exactly in this bracket that I'm showing here, but cutting metals by hand, you never get a true cut. So it's better to have some kind of a jig that you can mount the tool, like I show in my other video. One of my grinders, Makita grinders, is set up that way, and then a Ryobi grinder, I use it, for shaving things, and so I have two grinders. Actually, I have three. Another little one, do this for smaller stuff. And you got to have a welder, something that is going to allow you to weld these things. This is just wire. I guess that's MIG welding. I don't use gas. I don't use anything. I just direct it from the wire, and I just take my time. It's something that you have to kind of learn to not to go too fast, and I do it in circles. Little circles like that on where these things match at or where they mate at 90 degrees. So I kind of go on a 45 degrees, and I just take my time. I grab the tool with my glove. One side, my other hand doesn't have a glove. Because I get better sensitivity and control that way. But this one, it's holding the hot end, so near the hot end, it's right there, and I hold that, and I just take my time, and I just wiggle, the tool around, boom, 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 in little circles, and that's how I get my bead of weld. Till you got to wait till the metal is truly molten, you know, where it's red hot, where it builds, you know, the little, where it builds, you know, a good amount of metal around the joint, and that's where you have, that's when you have a good joint. So it took me a little while to, you know, to get the hang of it. Now you know, now I got the hang of it, and so how I did these, well, and then I come back with a thick disc grinder, you know, because it's thicker and it's got a sort of a curvature at the edge. I come back and I round these things off on the outside. The inside of this, I did it on a mill, you know, just a vertical mini mill that I have, and I took my time, you know, little by little, kind of letting the mill grind the grind a curvature here to remove some of the imperfections of the welding. So it's welded on the inside as well as on the outside right here. You can see how I curved that here on a grinder and on a belt sander, which I also have. You know, so these are the tools that you need. You know, you can't do this with you know, if you're going to do something like this, you got to have the tools. You can do it with just some basic hand tools, but it's better to, you know, the more tools you have, the better. You know, you're off. That's what I'm trying to say. And so I'm very glad that I did it this way, because this 3/16 is providing a solid control here. There's no flexing, no wobble, none of that stuff. And it's very positive the way I did it, and I explained that in my other video number, I believe it's video number 9, where I focus in on how I did this with the with a spacer inside here to reinforce this. This is solid, and I would even say that it's better than some of those C brackets that are welded, you know, with the camber and the caster on the bar itself. So I don't have caster, I don't have camber. It's working beautifully. I'm going to remain with this setup here. My other go-kart that I did based on a real racing go-kart dimensions and size, that one has caster and camber, and it's a lot more complex, and I'm having issues with the steering on that one. It's not as precise as this one right here. This one, with the geometry that we have here, the way this came out, as I was saying in another video, I wish these would have been more parallel with this bar right here, and that way you have, you know, true control without any deflection in angles or one side more than the other. True parallelism, you know, in those controls is ideal, but unfortunately I couldn't get that because of this arm here that I'm using for the steering, you know, with these ball links. Any lower than this to obtain a more parallel mechanical setup here would have interfered with this section here. Would have, you know, been touching the plate. So I left it at that with those angles there, and it's I did have to make my wheels with a little bit of not in toe. Not in toe would be the wheels pointing like this, but out toe. So they have a little bit of not pitch and toe, but you know, outer toe, just a slight bit. So when I do my control, I can get this wheel to come in a little bit tighter in angle than that outer wheel, the way it should be, because, you know, the radius between this distance right here, you know, you want this wheel to be a little bit inward. And it's working out beautifully. I mean, you can tell also by the wear of the tire. There's no excessive wear on either side of this center section here, this track right here. So it's wearing it on the center, which is an indication that you have a you know, positive, good steering angles and setup. So I am very happy with that. This right here, the way I did this. And of course, I have this. This is just a bike light. I did this for my scooters. I bought this for my scooter, so I ended up putting this because I've been riding at night. A great little light, but I got I'm ordering lights so that I can put them here so it looks cool. Let me shut this off here. So it looks, you know, a little more. I mean, I want this to look really nice. It's coming out. It came out. It's a nice frame. It's a nice little go-kart, you know, with the way I'm doing it, and I just want the lighting to add those finishing touches there. I don't, you know, this is for a bike, this is for a scooter, you know, but I want some really cool lights right there. So I found them after searching high and low for them again, because I'm very particular about, what I want. And I also buying two of the same ones that I'm going to use at the front, the white ones, same white ones going to go in the back. And I think because I couldn't find red ones, I'm going to use those and modify those with my own circuit so that I can turn them as blinkers. So I can blink them. I don't need fancy blinking or modes, like some of these lights for bikes and electric scooters have. So I'm going to do my own circuit, just a blinking circuit that I can turn on with blinking, but I also have a connection for the brakes. So when I activate my brakes, either through a brake like this one. I forgot I had these, so I've been using these buttons here, for braking. And I found this, and I go, duh, this already has the wiring for braking. So I'm going to either use this on. I'll probably just use this on the handlebar instead of the feet, because then now I need special brakes for the feet. So just to keep that clean. So I'm going to use this for my braking. And I'm going to connect that to my circuit that I'm going to design, for the rear lights, which are basically the same white front lights, but I'm going to put red filters on them, so that I can get the red tail lights. They'll be blinking, for while this is running at night. But anytime I brake, they'll come on either brighter or just brighter or just full on, so that's what I'm going to be working on. The other thing that I'm going to not modify, but change is, or modification, I guess you can call that a modification, is this bracket right here. The way I did this is also another maker pipe connector that has two side clamps, so you can connect individual handles here. I'm not liking this because this is not this is wobbling a little bit, but it also has to do with the fact that this handle system here requires a certain diameter, and this pipe right here, the EMT tubing, 3/4 EMT tubing, is just too big, so I had to put this on my lathe and grind, shave some of the surface here too, so that it fits here. And although I did it pretty precise, for about an inch, it really requires this to be done, almost the full length of the pipe, to this point right here, so it engages completely on the handle, all the way through the inside cavity of this handle. So I'm going to do that, but I'm going to use also a single piece tube. I want to change this to just a regular bracket like that, so that I can go with a full length instead of two side tubing, just with a full length right there. That way it'll have, I think, a little more positive mechanical assembly, or not reinforcement, but just a little more positive feel. Because this does have a little, very minor, but it is things that bother me. So I'll have a full bar right here, and I'm going to have to do the same thing to the other side of this bar, shave it so that it fits. Actually, this one I don't think I need to do anything here, because this one has a rubber. Yeah, this is just rubber, so the rubber kind of fits over that with a little bit of pressure, which is not. I'd rather have a little pressure there than be too flimsy or too loose. So that'll just go straight in. I do have some mirrors also that I order, which I was kind of I should have a mirror here in case, because I run these by the bicycle paths here where I live, and I have to kind of turn back my head to see if there are any cars coming. So a mirror would be nice and handy. So the single bar right here will have also a room, just like this light right here is done. I'm going to remove this light and maybe just put the mirror, maybe two mirrors, right there. All I need is just one mirror on this side, because this is where the traffic comes in, on bicycle paths. But two mirrors will balance it out, keep it symmetrical, which is what I like. I mean, I like my projects with symmetry. So yeah, that's what I'm working on. The other thing that I'm going to do, I believe I do have 3 shock absorbers that I bought for my racing go-kart, and I never installed it there because I was trying to think of ways how I can do that cleanly. But think I'm going to use two of those here because this lends itself more for the use of those shock absorbers the way that I did the seat here. The way the seat here is attached to individual pieces of this tubing, saddle mounted over the center here. And so if I put a pivot point right at the center here of this seat here, just raise it maybe another inch, I can put the shock absorbers. You know, I'm going to have to manufacture some kind of a bracket that clamps under from underneath this center the center section here, and just have two shock absorbers on the sides here where the seat rides on top of them, and that way it'll give me cushion. That way I don't have to modify, you know, the frame, because the frame I want it solid. So I just need the seat to be, you know, to have shock absorbers. So I think I'm going to do that. And that should, besides the panel that I need to make, also I need to make this panel right here, a nice spiffy panel. But I'm going to take my time doing that. That's going to take I don't know, another couple of days. So I want to design that on the computer and 3D print it. And once I get that one tested, it'll probably be done in PLA just for the sake of getting the first prototype done. Any modifications, any tweaking, I'll do it, and then I'll finalize it in an ABS setup, or maybe just do it out of aluminum with a nice cover there. So, because I do have more of this stuff right here from this wheelchair, you know, that my neighbor gave me. So, so, you know, repurposing stuff like that. I mean, I really enjoy repurposing things, especially, you know, when you're putting things to projects like this to good use. You know, you're not wasting materials, you're not throwing it away, keeps it away from the landfills, and you're doing something useful and fun, you know. So I think I'm going to do that. So once again, these are the receptacles for my 18-volt Ryobi batteries, which are working great. I have another little scooter here that I took apart. These have smaller wheels. This one, I'm gonna, as I was saying, I want to do two more of those, two more similar go-karts with this architecture here for my grandkids, but smaller version, you know, not as powerful. And I'm going to be using these smaller wheels, you know, on those right there. Similar setup. I'm going to remove all these electronics and do, you know, separate controllers, you know, with a speed control that is set up to a lesser, more slower and lesser powerful setup, so they can run these things really slow in my backyard. So that's what this one is for. But yeah, these are the parts. This is basically how I'm doing these things right here. And hopefully I'll be able to do a video. Somebody can videotape this, or I can videotape somebody running this, and you can see the how this go-kart is really performing so much better than my racing go-kart that I did, like I said, a while back, the yellow one that I show. That one I'm just going to take my time. I'm going to let my mind fully saturate and finish this project. Then I'm going to go back to the racing go-kart and modify the front end here so that it gives me a little more positive and more precise steering, because that one, the steering is also wearing out my batteries, because it's making one of the wheels rub as I turn. It's what is that called? I think it's called rubbing, or so I'm going to do that once my mind is free from this project right here. But this is where my mind has been at lately, and you know, I switch projects left and right, and that's just how my mind works. If I get inspired, I may get inspired by something else in the process of doing this, and so I tend to jump, you know, from one to the other. And the only problem with that is that I never finish these things quickly enough as I would like to finish, but eventually I get to them at some point. Mario once again with MIA Microflight. Stay tuned for the continuation of this cool project. Thanks for watching.